Hello everyone and welcome back to Math Merit. Today we are going to be continuing with concept number 2. Last class we worked on the same concept, which is solving systems by graphing. And we did that with two linear equations. Today we're not starting off with a linear equation. We are actually starting off with information that we need to be able to create an equation that we can graph. Okay? Now, what are we doing today? We are comparing two different types of data. We have time and we have weight. Now, we have two specimens, alligator 1 and alligator 2. For alligator 1, we start with an initial weight of 4 pounds. Remember that. Or write it down in your notes. Then we have rate of growth, which is 1.5 pounds per month. Okay? For alligator 2, we have an initial weight of 6 pounds. A rate of growth of 1 pound per month. Okay? So the time lapse that we're using is months, and the weight that we are going by is by pounds, not ounces or anything like that, just pounds. So what are we going to do with that information? What we're going to be doing with that information is we're going to be creating our equations. Now, we're going to let the alligator weight be the initial weight. Okay? So the information that we had down for alligator 1, which is initial weight, is going to be the alligator weight. We're going to add that to growth rate, which is going to be multiplied or times time. Okay? So it's going to look a little like this. We have to find the alligator weight. So we're just going to use our variable W. And we know W is equal to the initial weight, which for alligator 1 was 4. So it's going to be 4. And we are going to be adding to that the growth rate multiplied by the time. Now the growth rate for our first alligator was 1.5. And we're multiplying by time. We weren't asked for a specific time, so we're just going to leave it as a variable. We're going to put time t. Okay? Now this might look a little off, but somewhat familiar at the same time. Now let's work on our alligator 2. Same thing. We have W equals our initial weight for alligator 2 was 6 pounds. And of course, we are adding that to 1 pound in t time. Again, we are using the variable t for time because we were not asked for a specific time. Okay? Now, do those look familiar? They kind of look like linear equations, but they're kind of out of order at the same time. But our slope is still our slope, and our y-intercept would still be our y-intercept. Now, looking at it like this, our slope would be 1.5t, and our y-intercept would be the 4. Okay? Now, to graph, we are going to use our method that we always do, which is elevator, elevator, walk. Now, I know it looks a little out of order for what we would usually use for elevator, elevator, walk, but we also have to identify our slope and our y-intercept, which in this case, they're going to be switched places. Our y-intercept in this case is going to be 1.5t. Now, 1.5t in fraction form is 3 over 2. So let's just replace that 1.5 with 3 over 2, just to make it easier when graphing. So 3 over 2. Okay? And our slope is 4. Let's go ahead and graph our first linear equation, and that is going to look like this. We're going to start off with 4. That's going to be our first elevator. So we're going to go up 4 times. So right here is our first point. Next up, we're going to go up 3 and over 2. So elevator, up 3, 1, 2, 3, so 7, over 2, so right about here. Right there. Very nicely. Now, let's draw our line across. I need a ruler for this. Okay. Now, let's go ahead and graph our alligator 2 line. So, again, same thing. Our slope is 6. Our y-intercept is going to be 1t. So, let's go ahead and graph it. We're going to go up 6. So, right here, we're going to go up 6. Then we're going to go up 1 and over 1. So, right here. Right about here. Now, let's go ahead and draw our line. So, it's going to look like this. Alrighty then. That is our line for alligator 2. Now you see where these 2 lines intersect? These 2 lines intersect where both alligators weigh the same amount. So they weigh about, I want to say 9 to 10 pounds at around 4 months of age. So our x would be 4. And our y would be, let's say, 10. And that just tells us that around 4 months of age, both alligators weighed 10 pounds. Do you guys get it? Let's go into your assignment for today. For your assignment today, what I want you guys to do is follow the same steps I just followed and graph these 2 comparisons of the 2 alligators. So you're going to be solving the system by graphing. Okay, so pay attention. Initial weight this time for alligator 1 is 3 pounds, but the rate of growth is 2 pounds per month. Now for alligator 2, the only thing that changed was the initial weight. It went from 6 to 8 pounds, and the rate of growth is still 1 pound. So just plug it in using your notes. You should have taken out of the formula how we did it. And if you have any questions, please don't hesitate and ask. I am here to help. And I hope you all have a very wonderful rest of your day. Goodbye.